Hello and welcome to today's meeting. Today we are going to look about, or we are going to look at a particle model of matter, and we are going to look at diffusion. So you remember previously we have looked at particle model of matter, solid, liquid, gases. Now we are going to look at particle model of matter. We're talking about what? Diffusing of gases. All right. So our lesson objectives, by the end of this lesson, you should be able to define diffusion, give examples of diffusion, explain diffusion in terms of the particle model of matter, and compare diffusion in liquids and gases. All right. Now let's look at an overview. In what way do the particles of liquids and the particles of gases behave in a similar way? So you remember the answer to this is that liquid particles and gas particles are able to move freely. So it's like a similarity between the particles. So I repeat, in what way do the particles of liquids and the particles of gases behave in a similar way? They behave in a similar way in the sense that they are all able to move freely. When I say all, referring to liquids, particles, and gas particles. All right, now let's look at diffusion. And what is diffusion? So take note, by the end of this lesson, you should be able to do what? Define diffusion and give examples of diffusion and explain using the particle model. So what is diffusion? Diffusion is a process in which the particles move from a highly concentrated area to an area with a lower concentration of those particles. Repeating, is a process in which the particles move from a highly concentrated area to an area with a lower concentration of those particles. Diffusion only takes place in liquids and gases. Take note, diffusion only takes place, or we can say diffusion only occurs in liquids and gases. Now listen, concentration refers to the number of particles in a certain area. A higher concentration contains many particles, and a lower concentration contains lower or fewer particles. Diffusion is faster in gases than in liquids. Now, why are we saying diffusion is faster in gases than in liquids? So, for example, let's say that I am at a corner of the room, and then I have a spray or an aerosol. I press. When I press, then I'm going to get some what? Some gas particles coming out. So where the corner I'm standing at, and then I spray, the particles around there, they are many or more. They are concentrated. So the particles at where I am standing and spraying, they are more than the other side, than the other corner or the other part of the room or hall. Now, so because of diffusion, these particles will start moving from where they are more or plenty or many to where they are less or few. So that is a diffusion for you. And because they are gases, then they move faster. So diffusion is faster in gases than in liquids. Okay. All right. Now, if you are following, answer this question. Diffusion is faster in gases than in liquids, true or false? Diffusion is faster in liquids than in gases, true or false? Okay. Hey, diffusion is faster in gases than in liquids. It's true. All right. Now let's continue. And what is diffusion? What is diffusion? What is diffusion? In your own words, what is diffusion? What is diffusion? What is diffusion? Yes. What is diffusing? What is diffusing? Yeah, somebody has given us, yes, I need more. I need more definitions or explanations. Yeah, that's not enough. It's not enough. Natalia, yes, it's not enough. I need more and exact to the point. Okay, so all of you who did send in your answers, well done, you have done well. Now listen to the definition again. Diffusing is a process in which particles move from a region of higher concentration to a region of what? Lower concentration. So you see this definition, you will encounter it even as you go get to grade 10, grade 11, and grade 12. Maybe there will be just some few additions. Yes. So take note of it. So I hope perfect, perfect. Yeah, I think it's enough now. Lynn just said that what I wanted. Okay, now let's go on. Now answer this question for me. Diffusion only takes place in liquids and gases. True or false? Diffusion only takes place in liquids and gases. True or false? Perfect. I like the way you are engaging. That's nice. All right. Fantastic. Let's go to the next. Now, gas particles move more quickly and at a greater speed, and therefore they will move more quickly from a higher concentration to a lower concentration. So this point is explaining why gases uh, uh, move faster than what? Liquids. Just an addition. The speed at which particles diffuse depends on the size of the particles. One, and the state of the particles and the temperature of the particles. So what does that mean? So when we are talking of the movement of particles, that is from a region of higher concentration to a region of lower concentration, there are certain factors that determine the speed at which the particles diffuse. One of them is the size of the particles. If the particles are small, then they will diffuse faster. If the particles are large, they will diffuse what? Less fast or slowly. Now, so what it means is that when we talk of the size of the particles in relation to diffusion, we can therefore conclude by saying that the smaller the particles, the size of the particles, the faster the rate of diffusion. And the larger the particle size, the slower the rate of diffusion. Okay, now let's look at the state of the particles. When we are looking at the state of the particles, are the particles solid? Are they liquids? Are they gases? Or are they in powder form? Or whatever. Now, so if the particles are gases or gases compared to liquids, then it is expected that the gases will what? Diffuse faster because they are moving quicker than liquids. So gases diffuse faster than liquids. And finally, the temperature of the particles. Now, whether the temperature is low is having an effect. And when the temperature is high, is having an effect. So in terms of temperature, we say temperature is the what? Average kinetic energy. The average kinetic energy of what? Particles. So if the, okay, well, let me use this one that you understand. The temperature of an object is talks about how hot or cold an object is. So if the object is hot, then it means the particles have got more or high kinetic energy to move about. So if they have got high kinetic energy to move about, it means the rate of diffusion will be high. But when we compare to a situation in which the temperature of the particles is low or are low, then what it means is that they have got less kinetic energy. And when we talk of kinetic energy in terms of rate of diffusion, the lesser the average kinetic energy of the particles, the less the motion or the movement or diffusion of the particles. I hope you understand that concept. All right. Now let's look at another conceptual development in terms of diffusion. So we say in diffusion is a place in which the particles in liquids and gases move from a place where there are many particles to a place where there are fewer particles. A similar example is when I was talking about the aerospray or a perfume, in which you will be at one place or at one corner and then you spray. So that is just diffusion for you. And diffusion occurs only in gases and liquids. And the particle model of matter explains diffusion as well. Okay, now listen to what the particle model of matter is talking about diffusion. Diffusion occurs because particles of matter are in continuous motion. So, because the particles of matter are always in motion or moving about, therefore diffusion takes place in gases, faster in gases than in liquids, because the particles in a gas move more quickly than the particles in a liquid. The rate at which particles diffuse depends on the size of the particles, the state of the particles, and the temperature of the particle. So now, if I ask you, how do you use the particle model of matter to explain diffusion? You will simply say diffusion occurs because particles of matter are in continuous motion. Take note, I will ask you just not far from now, but I will wait. All right, now let's look at this. This is diffusion. We're looking about gases. Have you ever noticed how quickly smells travel? Perhaps you have walked past a rubbish bin and smelled the garbage. Okay, so if you have ever walked past that, then you can often smell garbage bins when you walk past them. Has anyone ever set off a stick bomb near you? That's bad. So all of them involve gases and they move. Why would you smell it when you are passing by the rubbish bin? No, you pass by it because the particles there in gaseous forms try to diffuse. Whether somebody tells it to do so or not, it will naturally do that. And according to the particle model of matter, gases are always, yes, because of diffusion, perfect. Gases are always in continuous motion, and because they are in continuous motion, hence diffusion occurs. All right, so this picture you are seeing are just illustration of what? Diffusion. Okay, if you have any question, you might ask. Now, we have been talking about diffusion in what? Gases. Let's look at also diffusion in water particles. Now, just look at these two. What will the mixture look like when the colored particles are uniformly spread out among the water molecules? Yes, so all the water molecules will look like this, almost yellowish. Now let's go on. Now, a particle in a liquid cannot travel very far before colliding with another particle because the particles are so closely or close together. Let's take it again. A particle in a liquid cannot travel very slowly, very far before colliding with another particle because the particles are so close. That means the liquid particles are constantly colliding and are set into a new direction with each collision. This means that the rate of diffusion is much greater in liquids than in solids or gases. Okay, so that means that the liquid particles are constantly colliding and are sent into a new direction with each collision. This means the rate of diffusion is much slower in liquids than in gases, and even much slower than in solids. Because the particles of gases are further apart and collide much less, gas particles can travel further without being sent in a difficult situation by collision. This is why gases diffuse more quickly. All right. Now, the following table shows similar zigzag drawings as you saw before, but now you cannot see the difference between the random movement of a particle through a liquid and through a gas. It will take the particle much longer to travel from A to B in the liquid than in the gas. So what does that mean? So here we call them Brownomian motion. Okay. But even if you have a problem with that, when you get to grade 9 or grade 10, you may hear that in life science. But what it simply means is that if you look at A to B, so for example, let's say that this is a liquid particle, and from A to B, it moves faster. So let's say if it moves 2 minutes in liquid from A to B, then what is going to happen is that from A to B, so I said this is 2 minutes or 2 seconds, then A to B, it will take 30 seconds because the gases move faster. So you have to take note. Okay, now let's look at, before I go on to the factors, now I want you to answer this question for me. Mention the three factors that affect rate of diffusion of particles. Mention the three factors. Mention the three factors that influences the rate of diffusion. Mention the three factors that affect the rate of diffusion. Let me see. Size, state, and temperature. That's perfect. That's perfect. Perfectly. That's perfect. All right. Okay. That's a good. Natalie, what are you saying? Let's go to the next. Now, factors that affect the rate at which particles diffuse. One, the speed at which particles diffuse depends on several factors, namely the mass of the particle. Lighter particles will diffuse faster because on average they move faster. State of the particles. The speed at which particles diffuse depends on several factors, namely the mass of the particles, Now, this is the explanation. I already said that, but let's continue. Lighter particles will diffuse faster because on average they move faster. Then let's look at what the state of the particles. The particles in a gas are always moving fast. We say their average speed is high. The particles in a liquid travel more slowly. So take note. The temperature at each, the temperature of the particles, that is temperature is a measure of the particles in a gas. Okay, we have already said that. Move faster. We say they have got average speed is high. The particles in a liquid travel more slowly. Now, solids cannot come in here because we said diffusion only occurs in liquids and gases. Now let's move on the temperature of the particles. So we are explaining the points now. Temperature is a measure of the kinetic energy of the particles. The higher the temperature, the more energy the particles have, and the faster they will move and diffuse. The size of the spaces between particles. If there are large spaces between the particles, between the particles of one substance, the particles of another substance can move into those spaces easily. Okay, now we're going to look at, I've already used this example, but we are going to use it to explain. Spray a deodorant. So if you are at home or wherever you are, after this class, you can take a deodorant, spray in front of the class or in your room, and ask your brother or whoever is at home to stand when they smell the deodorant. So meaning in the classroom, they will be moving, they will be moving. Immediately they feel the smell of the deodorant, then they can stop. Two, when the deodorant particles leave the can, they move randomly, colliding with each other and spreading through what? The room. The area around the room has a high concentration and then a heat. So let's go on. The area around the can has a higher concentration of deodorant particles because there are many particles. In the rest of the room, the concentration of deodorant particles is very low. So drop a potassium permanganate crystal in water. Let the learner observe how the purple color diffuses through the water. It will take a while or other water to turn purple. Alternatively, use a few drops of what? Food coloring. So when we are talking about this, then a typical example is this one. This is the coloring. So when you mix it there, then you can see what diffusing occurring in what liquid. Okay. Now, so we are going to, if we were in classroom, we would have done this, but actually we have got that picture I've given you there. So different substances diffuse at different rates. So liquids and gases will diffuse at different rates because of the size of the particles or because of the temperature and then the average kinetic energy. So different substances diffuse at different rates. Diffusion is a device. Diffusing, is faster in gases than in liquids because gas particles have greater kinetic energy. They also move more quickly and the particles are further apart. This makes it easier for particles to move from one point to another. As a result, the gas particles will spread out quickly to fill the space evenly. So this is just the explanation how or why gases diffuse faster than in liquids. So we compare the kinetic energy of what the gases and then the liquids. So for gases, the average kinetic energy is higher than that of liquids. So they are able to move quickly, more quickly, and the particles are also further apart. The particles this makes it easier for the particles to move from one point to another. As a result, the gas particles will spread out quickly to fill the space evenly. So take note of this. A particle in a liquid. So now this is the explanation for what? Liquid. A particle in a liquid is constantly colliding with other particles because the particles are so close together. The particle cannot travel very far because it is sent in different directions and eventually makes it to move slower or lower concentration of the particles. All right. So when we are using a particle model of matter, this is a perfect explanation to illustrate that. Now, so take note. It's now your turn. You ask any question. Before we do this question one or checkpoint one, what is a diffusion? Do liquid particles or gas particles diffuse faster? Then you send in your answer. Let's be fast. Let's be fast. So I can hear some of you are asking whether we are going to do Kahoot. We can do Kahoot, but or last week work because I didn't plan for us to do Kahoot, but your results for the game we played last week was not that good, so we can play that one also if you don't mind. Yeah. Yeah, very good. I can. Diffusion is when particles move from highly concentrated area to low concentrated area. That's good. That's a nice attempt, Lean. Okay, let's go on. Perfect. So do liquids, particles or gas particles diffuse faster? Gas, that's perfect. I like that. So let's see your answers. All of you, you have got that right. Perfect. So you have got total marks here. You see the answers. Diffusion is the movement of particles from area of many particles to an area of fewer particles. It's the same thing as saying diffusion is the movement of particles from from high concentrated area to a low concentrated area. Yeah. Um, yeah, 100% perfect. Now, and then B is gas particles. That's perfect. You know how to score. Perfect. 2 out of 200%. Now, let's go to the next question. Let's go to the next question. Yes. Why do gases diffuse more quickly than liquids? When will the process of diffusion stop? So take note. Yes, send in your answers. This one is a bit tricky, but it's simple if you were following. The other one, you got total. Let's see whether you will get total here. I know you can get it. All right. Yeah, I can see your answers. Someone is saying they are more separated than liquids. Okay. Someone is saying because gas particles move constantly and faster than liquids. All right. Someone is saying there is more spaces in gases for diffusion to occur. Okay. Yes. Send in your answers before we move to the next. Before we move to the next. Yeah. And then don't forget there is B also. B is saying, when will the process of diffusion stop? Yeah. Don't forget. When will the process? Yeah. B. When will? Hey, Natalie, you got it, ne? That's good. That's great. I wish you send me a private so that people they won't see it. But let's see, I'm sure they won't copy. Yeah. So somebody already got B, but let's see whether the others will also get it. Yes, let's go on. All right. So I can see only one person, only Natalia sent in the answer. I'm waiting for the rest. Okay, let's go on. When the substance is equal in both areas. Okay, that's perfect. Now check, let's check our answers. So let's see those who will get this time around two, that's four, A 2 marks, B 2 marks. Let's see the one who will get total 4 marks, 100% again. Let's see. All right, so let's check. Checkpoint 2. Why do gases diffuse more quickly than liquids? The answer is gases diffuse more quickly than liquid because the particles have more spaces to move in, and they also have more energy, so they move faster. Did somebody get that? That's too much. And B, when will the process of diffusing stop? Diffusing will stop when the concentration of the particles is the same everywhere or is equal. That's perfect. So yeah, I can see that. Now, what we are doing when you go to grade 10 or grade 9 in life science, these things are the same. Yeah, just with just some few addition in diffusion. You'll be talking about diffusing in plants, diffusing in animals. But for now, generally, what you have done with diffusing and then the particle model is perfect. So take note, don't forget it. Yes, we have got diffusing in plants and diffusing in animals, how they take in water and other things. So for now, you will you 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 will get other things. So for now, our syllabus is, we are not talking about diffusing in plants and animals. But when you move out to grade 9 or grade 10, maybe. All right. Now let's continue. Let's see. All right. So don't always forget. So now today last week we looked at comparing between gases and solids and liquids also. Now we are going to look at liquids and gases. So see, the reason why gases move faster, the spaces between them are too big or too much.